Good morning class. Today we will discuss about chemical properties of cyanides and isocyanides. In the last segment we discussed about general methods of preparation of cyanides and isocyanides, but today we will discuss about the general methods of preparations of, in the last segment we discussed about general methods, but today we will discuss about chemical properties or chemical reactions of cyanides and isocyanides. Now, so we are going to discuss about chemical properties of cyanides and isocyanides. Chemical properties of cyanides and isocyanides. Chemical properties of cyanides and isocyanides. So, when we are discussing about chemical properties, we have to discuss 5 major chemical properties of cyanides and isocyanides. The first one is hydrolysis, the second one is reduction, the third one is reaction with Grignard reagent, the fourth one is reaction with, or we can say addition reactions, and the fifth one is rearrangement reaction or isomerization. It can be said in any other one way. So, the first one is hydrolysis or reaction with water. Hydrolysis or reaction with water. So, first of all, when we are discussing about hydrolysis, we will discuss it is in case of cyanides. Let us discuss the hydrolysis in case of cyanides. When we are discussing about hydrolysis of cyanides, the first one is hydrolysis in acidic medium. The first one is hydrolysis in acidic medium. Hydrolysis in acidic medium. Then how does it take place? Let us see. First of all, let us take a cyanide. This is cyanide and it is treated with in acidic medium, or it can be said that it is treated with water HOH. This is, since methyl group is attached, it is called methyl cyanide. This is common name, or the IPC name would be methane nitrile, or the IPC name would be methane nitrile, and this is water. When it is treated, it forms CH3 C double bond NH2. It forms acetamide. Amide is formed. And on further hydrolysis, when it is further treated with water, on further hydrolysis, what happens? This H2, or it can be said like this, it forms this NH2 combines with this hydrogen to form ammonia. A molecule of ammonia is eliminated and this OH is introduced over here. It leads to the formation of CH3 C double bond OOH. This is commonly called acetic acid, or its IPC name is ethanoic acid. Its IPC name is ethanoic acid. This was the first case of hydrolysis in acidic medium of cyanides. Let us see in case of basic medium. Reduction of cyanides in basic medium. What happens in this case? Let us see. Let us take the same compound, that is CH3CN. Again this is methyl cyanide. This is methyl cyanide. When it is hydrolyzed, what happens? It leads to the formation of CH3 C double bond O NH2. This is acetamide. Acetamide is formed, and when it is further hydrolyzed, in basic medium, what happens? A molecule of ammonia is again eliminated and leads to further formation of CH3 C double bond ONA. This is called sodium acetate, its common name, or IPC name would be sodium ethanoate. Common name is sodium acetate, or the IPC name would be sodium ethanoate. So, this is the hydrolysis of cyanides, first in acidic medium and then in basic medium. When a cyanide is hydrolyzed first at the first level, it leads to the formation of acetamide, amide is formed, and when it is further hydrolyzed in case of acidic medium, what happens? NH2 combines with hydrogen to form a molecule of ammonia, and this OH is attached over here. It leads to the formation of acetic acid, or it is also known as ethanoic acid. But when cyanide is treated with water first in case of basic medium, the first step is same, again amide is formed, and when it is further hydrolyzed in case of in presence of a base, again a molecule of ammonia is eliminated and leads to the formation of sodium acetate or sodium ethanoate, and a molecule of ammonia is again eliminated. So, in both the cases, the first step is same, that is formation of amide takes place, but the difference is observed in the case of second step. In case of second step, there is, in case of acidic medium, acid is formed, carboxylic acid is formed, but in case of basic medium, sodium salt of carboxylic acid is formed, because it is treated with a base NaOH, because we are hydrolyzing it is in basic medium. Now, next is hydrolysis of isocyanides. Hydrolysis of isocyanides. So, what happens in this case? Let us see. We have a isocyanide, let it be CH3NC. This is methyl isocyanide. This is methyl isocyanide. When it is hydrolyzed with water, what happens? An intermediate compound is formed which has a structure like this, CH3 NH, and here we have C double bond OH. A structure like this is obtained, and when it is further hydrolyzed, what happens? This hydrogen atom is attached to this nitrogen atom, and this OH group is attached to this carbon atom. This hydrogen atom, when attached to this nitrogen, forms NH over here, and when this OH group is attached to this carbon atom, it forms a C double bond OH, an aldehyde group is formed. But when it is further hydrolyzed with water in acidic medium, we are discussing in acidic medium. So, what happens again? Bond cleavage will take place over here. This H plus ion attached to this nitrogen atom, and this OH minus is attached to this side, and the bond is cleaved from here. So, it leads to the formation of CH3, and this is NH2, and further it through the formation of CHO, this is formic acid, HC double bond OH, HC double bond OH. So, this is amine, and since CH3 group is attached, it is called methenamine. It is called methenamine, and this is commonly called formic acid, or its IPC name is methanoic acid. So, this is the hydrolysis of isocyanides in acidic medium. I repeat, isocyanides cannot be hydrolyzed in basic medium. Isocyanides can only be hydrolyzed in acidic medium, whereas in case of cyanides they can be hydrolyzed in both the mediums, in acidic medium also, in basic medium also. But when we are discussing about isocyanides, they can only be hydrolyzed in acidic medium, they cannot be hydrolyzed in basic medium. So, when a isocyanide, let it be methyl isocyanide, when it is treated with water or hydrolyzed, so this hydrogen atom attaches to this nitrogen atom, and this OH group attaches to this carbon atom, leading to the formation of an intermediate compound like this. When it is further hydrolyzed, a bond cleavage will take place from here. This H plus ion is attached to this nitrogen atom, and OH minus ion is attached to this carbon atom. So, what happens? It leads to the formation of CH3NH2, this is methenamine, and this is HC double bond OH, this is formic acid. Now, this is the first reaction, that is hydrolysis or the first chemical property. Now, the next one would be second, and the second one is reduction. When we are discussing about reductions, the first category of reduction would be complete reduction. The first is complete reduction and the second would be partial or incomplete. So, first of all, when we are discussing about complete reduction, it is called Mendius reaction. It is a name reaction called Mendius reaction, most important. And first of all, we are going to discuss about Mendius reaction in case of cyanides. So, let us take the example of cyanides. Let it be in case of when we are discussing about cyanide, let us take the example of cyanide. Let it be CH3CN, let it be methyl cyanide. Let us take the example of methyl cyanide. It is getting reduced, means addition of hydrogen atom. So, let us add 4 atoms of hydrogen, since addition of hydrogen is a reduction process, and let us take a reducing agent, let it be lithium aluminum hydride. It is a reducing agent, that is addition of hydrogen. So, we have 4 hydrogen. Of these 4 hydrogen atoms, 2 are attached to this carbon atom and 2 are attached to this nitrogen atom. 2 are attached to this carbon atom and 2 are attached to this nitrogen atom. We have 4 hydrogen atoms. So, what will happen? It will form CH3, H2, and this will be NH2. This structure is formed, and since we have 2 carbon atoms over here, it is called ethanamine. And it is a primary amine. Later on we will discuss the different types of amines. Amines are of 3 categories or 4 categories: primary amine, secondary amine, tertiary amine, and even we have quaternary salts also. So, later on we will discuss, but since we have an H2 group over here, that means it is a primary amine, and since the carbon chain is made up of 2 carbon atoms, so it is called ethanamine. Now, after that we have the complete reduction in, first of all we saw in case of cyanides, then we will see in case of isocyanides. Complete reduction in case of isocyanides. So, let us take an example, let it be CH3NC, it is as isocyanide called methyl isocyanide. It is methyl isocyanide. When it is reduced, and that means when it is treated with 4 atoms of hydrogen, what happens? Again we need a reducing agent. Let the reducing agent be lithium aluminum hydride. So, what happens? Of these hydrogen atom, 1 hydrogen atom is attached to this nitrogen atom and 3 hydrogen atoms are attached to this carbon atom. 1 hydrogen atom is added to this nitrogen atom and 3 remaining hydrogen atoms are attached to this carbon atom, leading to the formation of CH3NHCH3. A structure like this is obtained. This is called, since we have NH group over here, so it is a secondary amine. And it is known as dimethylamine. Now, this was the complete reduction, or this entire process of complete reduction of cyanides and isocyanide is termed as Mendius reaction. So, what happens in case of cyanide? When a cyanide is treated with hydrogen atom in the presence of reducing agent lithium aluminum hydride, a primary amine is obtained, and since in this case we have a carbon atom of 2 carbon atom chain, So, it is commonly called ethanamine or its IPC name is ethanamine. Then we saw the complete reduction in case of isocyanides. Let us take the case of methyl isocyanide. When it is treated with 4 atoms of hydrogen, that is undergoing the process of reduction in the presence of a reducing agent, that is lithium aluminum hydride. So, one hydrogen atom is attached to nitrogen atom and the remaining 3 hydrogen atoms are attached to this carbon atom, leading to the formation of a structure like this. Since we have NH group of here, that means it is a secondary amine, or it is also known as commonly dimethylamine. It is also known as dimethylamine. So, this is the entire process of complete reduction, that is also known as Mendeus reaction in case of cyanides. And isocyanides also we saw. Next, this was the complete reduction. Now, let us see what happens again. Now, we are going to discuss about incomplete reduction or partial reduction, incomplete reduction or partial reduction, and it is also got a main name reaction. It is also called Stephen reaction. It is called Stephen reaction, again most important. The complete reduction of nitro compounds, that is in case of cyanides and isocyanide, is called Mendeus reaction, but when it is incompletely or partially reduced, it is called Stephen reaction. What happens in this case? Let us see. Let us take an example of cyanide. Let it be methyl cyanide again. This is methyl cyanide. This is methyl cyanide. When methyl cyanide is treated with 2 atoms of hydrogen plus HCl, 2 atoms of hydrogen and HCl, what happens? It forms a intermediary stage. One hydrogen atom is attached to this carbon atom and the other hydrogen is attached to this nitrogen atom. What happens? A structure like this is obtained, CH3, CH. Then we have here NH group, one hydrogen atom attached to this carbon atom and the other hydrogen atom attached to this nitrogen atom, and the HCl is attached to this nitrogen atom. A structure like this is obtained. This is called imine hydrogen chloride. This is called imine hydrogen chloride. This is called imine hydrogen chloride. Okay. Now, when it is further reduced, that is when further 4 molecules of hydrogen are added, what happens? Again a bond cleavage will take place from here. Of these 4 hydrogen atoms, 2 hydrogen atoms are attached to this side and 2 hydrogen atoms are attached to this side. Let us again see what happens. Again when it is further reduced, that is addition of 4 hydrogen atoms, a bond cleavage will take place from here. Of these 4 hydrogen atoms, 2 are attached to this side and 2 are attached to that side. A structure like this is obtained, CH3, CH3, this is ethane, and also we have a molecule of NH4Cl because already we have 2 hydrogen overs here. Again when 2 more hydrogen atoms are attached, it is called NH4Cl, it is ammonium chloride. So, this is the partial reduction, also called incomplete reduction, and it is known by a name reaction, that is Stephen reaction, and it is only possible in case of cyanide. Stephen reaction or incomplete reduction or partial reduction is not possible in case of isocyanides. So, we have taken the example of methyl cyanide. When methyl cyanide is treated with hydrogen atom and HCl, what happens? Of these 2 hydrogen atom, one hydrogen atom is attached to this carbon atom and the other hydrogen atom is attached to this nitrogen atom, and this HCl is attached to this nitrogen atom. What happens? It forms CH3CH double bond NH dot HCl. This is called imine hydrogen chloride, and when it is further reduced, that is further hydrogen atoms are added, that is it is reduced. What happens? This is divided into 2 sets. that is sets of 2 hydrogen atoms. Of these 4 hydrogen atoms, 2 hydrogen atoms are attached to this side and 2 are attached to that side, and a bond cleavage will take place from here. So, it will form CH3CH3, that is formation of ethane will take place, and here will we have NH4Cl. So, formation of ethane will take place and a molecule of ammonium chloride is formed. So, this was the incomplete or partial reduction or Stephan reaction in case of cyanides. It is not possible in case of isocyanides. Next is third one, that is reaction with Grignard reagent. Reaction with Grignard reagent. Reaction with Grignard reagent. So, let us see how the reaction will take place. Let us take the example of C2H5CN. This is called ethyl cyanide. This is called ethyl cyanide. When it is treated with Grignard reagent, let the Grignard reagent be CH3MgBr. It is called methyl magnesium bromide. Methyl magnesium bromide. When it is treated with CH3MgBr, what will happen? We know that nitrogen and of carbon and hydrogen, nitrogen is more electronegative. That means it will attract the shared pair of electron, pi electrons toward itself. As a result, it will have a pair of electron or a negative charge, and this carbon will have a deficiency of electron, that is formation of carbocation will take place. So, of these MgBr has slight positive charge and CH3 has slight negative charge. So, this MgBr part will be attached to this nitrogen atom and this CH3 will be attached to this carbon atom. So, it will form an intermediate stage of formation of this compound like CH2, C2H5, C, CH3, and here will we have N, MgBr. Formation of this step would take place, and when it is further hydrolyzed, that is acid hydrolyzed, that is we need excess of water molecule, that is 2 molecules of hydrogen, 2 molecules of water. When we have 2 molecules of water, we have 4 hydrogen atoms and 2 oxygen atoms. In the next step we will acid hydrolyze this compound, and we need to have excess of water molecule, like we have 2 molecules of water. In case of 2 molecules of water, we have 4 hydrogen atom and 2 oxygen atoms. What will happen? Let us see. Bond cleavage will take at 2 places, at here and one more at here. So, what happens? OH group would be attached over here, 3 hydrogen atoms would be attached over here, and oxygen atom would be attached over here. Let us see. Here in case we have 4 hydrogen atoms, here 3 and here 1 4. We have 4 hydrogen atoms over here, and we have 2 oxygen atom, 1 oxygen atom is here and 1 oxygen atom is here. So, it is a complete balanced chemical reaction. So, what happens? Let us see. The bond cleavage will take place from here. It will be C2H5, C, CH3, double bond O. It is a ketone and will be known as, here we have a chain of 4 carbon atoms. So, it is known as butane 2-one, it is a ketone. This nitrogen when combines with 3 hydrogen will form ammonia. This will form ammonia, and this magnesium on combining with bromine and OH will form MgOHBr, known as hydroxy magnesium bromide. So, this is the complete reaction of Grignard reagent, reaction with the Grignard reagent, and this was the case of cyanides. And in case of isocyanides, isocyanides do not react with Grignard reagent. Isocyanides do not react with Grignard reagent. They do not show reaction with Grignard reagent. only we have reaction of cyanides with Grignard reagent. Isocyanides do not react with Grignard reagent. So, what happens, let us see once again. This is ethyl cyanide. When it is treated with methyl magnesium bromide, this is the Grignard reagent. This CH3 would be attached to this carbon atom and this MgBr would be attached to this nitrogen atom. It will form an intermediate compound like this. So, when it is acid hydrolyzed in the presence of 2 molecules of water, we have 4 hydrogen atoms and 2 oxygen atoms. Bond cleavage would take place at 2 places. So, here 1 oxygen atom would be attached, here 3 molecules of hydrogen would be attached and here OH molecule would be attached. So, here we have 4 hydrogen atoms and here we have 3 and 1 4 and here we have 2 oxygen atoms. So, 1 oxygen over here and the second oxygen over here. So, it is a complete balanced chemical reaction. So, when the bond cleavage will take place, it will form a ketone. This will be C2H5CO CH3. This is called butane 2-on. This nitrogen on combining with 3 hydrogen will form ammonia and this magnesium on combining with OH and Br will form hydroxy magnesium bromide. So, this is the complete reaction.